This is a brief demo for our IoT project of an anti-theft system for home protection. So basically, we are using different sensors to monitor the whole process of any entrance of the house. Like you can see this part as a door frame, and there are a bunch of ultrasonic sensor attached on it. And this part is the pathway through which any incomer should walk for a few steps after the entrance. Now let's move on to the detailed description of the whole embedded system.
Okay, the first kind of sensors we are using here is 5 ultrasonic sensors, and we located the 5 sensors in this way on 2 lines to improve the accuracy and reduce the response time. And next we will receive the signals from ultrasonic sensors to Arduino board because it can reduce the complexity of the circuit. And next is the vibration sensor here. So we will use it to detect the people's pattern, to the foot patterns, and because it will produce the digital signals instead of the it will produce the analog signals instead of digital signals. So the Raspberry Pi will only produce the digital ones. So we use the ADC converter here to convert the signals. And finally, we are using the Raspberry Pi here to finally process the data and train the data. Use a very powerful tool. It can provide us the graphic interface here, like a screen. So next up is the algorithm.
So this is the algorithm we use to achieve our goals. First, these 2 sub-functions we are used to do the data visualizations. In this one, we can get the score for each family members. In this algorithm, we assume that there are 3 family members in this house, and the A represents the possibilities that the person working is family member A, and then we can use a graph to visualize these scores, and then in these functions we can send them through email to each family members. And then it's the main part of our algorithms. We use 2 while loops to achieve our goals. The first while loops, we use the ultrasonic models to measure the height of the person walking. So basically, if there is a person walking in the room, the distance between ultrasonic model and the person will be smaller than 120 centimeters. And when this condition is achieved, this algorithm will start to store the distance, and then we can get the minimum distance. So, and we can compare the minimum distance to the height of our family members. If this condition is not satisfied, then the person working is a stranger, otherwise it's family members. To double check our result, we also use a kernel SVM algorithm to measure the vibration when the person walking in the room. And this very big matrix is the weight matrix we got through the whole training process via SVM. We will use it to test our result. This second while loop is the detailed SVM code. In this one, we will transfer all the vibration data into a big matrix and times it with W to get our score result. Finally, we will conclude the result got from ultrasonic modules and the vibration modules. If the person working can confirm both the ultrasonic conditions and the vibration conditions, we can make sure that he is a family member. Otherwise, we will say that he is a stranger, and we will send a message to the homeowners. That's the main part of our algorithm.
Okay, this is our experimental part. She's one of the family members. Comes in. Okay, let's start. Into the room.
So the score for Ruimin is very high compared to others, so we can draw the conclusion that the person is Ruimin.
got an email. Yeah, Remy comes in. It's our result. Okay, next, the family member.
And this one, the score for Minghao is very high, so Minghao comes in.
Okay, the results email is here. The picture shows that Minghao comes in.
Finally, let's see an example for a stranger.
Okay, here, alert a stranger comes in.
And we will receive an email to the homeowners.
The email is here. And we also got a message here to my phone that the alert stranger comes in. So it's the notification for our phones and the emails. Okay, that's all. Thanks.
Thanks.